I'm Kristen, and I'll be playing the teacher.
And I'm Breanna, and I'll be playing Ryanetta/Ryan for the Mr. Short, Mr. Tall problem.
All right. Breanna, since you said 2 paper clips per 1 button would not work because there are not enough paper clips, what would happen if we do 1 paper clip per 1 button?
Okay, so you have 1, 2, 3, 4. You have 1, 2, 3, 4, 5, 6. You have 2 left over.
So what can we do with the extra 2 paper clips?
I don't know.
Okay. What if I had a cookie and I wanted to share it between you and me? What could I do so that each of us get an equal piece?
Well, you just split it in half.
Correct. Now, if we had 2 other people with us and I had 2 cookies, how would we share the 2 cookies equally between the 4 of us?
So you split both cookies in half.
Right. So back to the problem. What can we do with the extra 2 paper clips?
Well, am I allowed to split them?
Well, how can we split them up?
Well, if I can split them in half, then I can give 1 half here, 1 half here, 1 half here, and 1 half here.
So how many paper clips per button do we have now for Mr. Short?
We have 1.5 paper clips for each button.
Right. So how can that help us solve the problem?
I don't know.
All right. How can knowing that each button equals 1.5 paper clips for Mr. Short help us determine how many paper clips for Mr. Tall?
Well, since they're the same size, can't I just count them out for like every paper clip for Mr. Tall or like the buttons?
Well, why don't you try and we'll see.
1, 2, 3, 4, 5, 6. Get 1.5, 1.5. And you add them, you 5, 10, 15, 20, 20, 30. And then get 3, 4, 5, 6, 7, 8, 9. And then you have the decimal point. So 9!
Very good. Now, looking at our relationship between the paper clips and buttons of Mr. Short and Mr. Tall, what do we notice?
I noticed that Mr. Short has 4 buttons for every 6 paper clips, and Mr. Tall has 6 buttons for every 9 paper clips.
Right. How could we write this as a proportion?
So you have 4 buttons to 6 paper clips. Oops, that's a 4. And then you have...
And who's that for?
That one's for Short.
Okay.
And then Tall, you have 6 buttons for 9 paper clips.
Right. So, do you see a relationship between Mr. Short's 4/6 and Mr. Tall's 6/9?
Well... Oh! They reduced to 2/3.
Right. So since you know that they are equal, let's start from the beginning of the problem. Originally, the only part we knew was that Mr. Short's height was 4 buttons or 6 paper clips. And Mr. Tall's height was 6 buttons, but we did not know how many paper clips. What is the ratio of Mr. Short?
4 to 6.
And what's 4 and what's 6?
4 buttons to 6 paper clips.
Right. So using this order and placement of buttons and paper clips, how would we set this up as a relationship to Mr. Tall's 6 buttons and unknown paper clips?
It would be 6 buttons. Well, from the beginning of the problem, you don't know the bottom part.
Okay. So why don't we choose a letter to represent the unknown? What letter would you like to use?
R.
Okay. So write R where the unknown paperclip goes. Perfect. We know the ratios must equal each other because we are using Mr. Short's button to paperclip ratio to get Mr. Tall's button to paperclip ratio. How would that look?
You get 4, 6 equals 6 over R.
And now what do we do?
Oh! You do that cross multiplying thingy. So you get 4R equals 36, right?
Right. Now how do we get R alone?
You divide by 4. R equals 9.
And is that what we got earlier?
Yes, it is.
Awesome. So now that we figured out that Mr. Tall's height is 6 buttons or 9 paper clips using the ratios for Mr. Short's buttons for paper clips, let's see if you can solve this next problem for me to show your understanding.
Easy peasy, duh.
Are you ready?
Yes.
I have 6 kids in my class.
6 kids in my class.
And I made 9 cookies. How many cookies?
9 cookies.
How many cookies did I make for 8 kids?
So now we have 8 kids. So. Okay. So you do this thing, right? Can I use an R?
Mm-hmm.
Equals like n. So you get 6 R equals 72. R equals. Is it 12? Do you get 12 cookies?
Very good.
Yay!
Yay!